Hello everyone, am I audible?
Yes, sir.
Okay. By the time everybody comes, please try to ask your problems. Uh, and the problems can be regarding anything that we have covered yet in integration. So I have taken the last class on integration using trigonometric identities, and I believe there have been one more class after that, and I wasn't available in that class. So if somebody can help me with the topic that you've done in that class, that would be good. Austin, were you present in the last class that was not taken by me? Okay, cool. Cool. Integration of some particular functions. Cool. So yeah, you can also ask your problems from this topic, integration of some particular functions, as well as integration using trigonometric identities. Anything that we have covered yet. Just feel free to ask me any question. If you don't have any problem, then let me start with some problems. And I'll also check whether you understood the concepts right or not. So please try to answer these questions. And let's start with some basic ones first. But yes, if anybody of you have any problem regarding the last two exercises or regarding anything in integration, then please feel free to ask. And jab tak koi, whenever you are not asking me anything, I will give you some questions. Please try to solve them. The first question is this. You have to integrate this function. So when I say that integrate this function, I mean that find out this. What will be the value of phi? You have to integrate 1 minus cos x upon 1 plus cos x with respect to dx. Please find out the answer. as soon as you see, first of all, uh, these problems are you can, I mean, and this is very easy to understand, which is the topic that the problem belongs to. For now, the problem belongs to trigonometric identities, right? You can clearly see that the function given is trigonometric, 1 minus cos x upon 1 plus cos x. And the second part, cos x minus sin x upon 1 plus sin 2x. So this is a standard question. This is also important. I would like to tell you this. This has been asked previously in the board's exam many times. So this is an important question, but also this is a very famous question. So I don't know whether you have solved this or not from the exercise, but if not, then please try to solve this now. And first question is basic, but not direct. It will not be solved directly. You will have to think about how, what particular identity you need to use here. How would you solve this? Anji, any idea for first part? Anybody? Just try to share your ideas. Try to share your methods, like I am thinking this to do, I'm thinking this to do. I will tell you whether it is possible or not. And if yes, then how, and if not, then why. So don't hesitate to ask dumb questions also. Don't worry. I mean, no question is dumb here. Yeah, anyone? Any idea how to solve first part? See, we can't take anything. I mean, substitution won't work directly. You can check this. The denominator contains 1 plus cos x. If you differentiate 1 plus cos x, then the differentiation of cos x is nothing but minus sin x, but you don't have minus sin x in the numerator. So substitution won't work. Now, what else we can do? Can we multiply the numerator and denominator by 1 minus cos x? Okay, try to go through this. If you multiply 1 minus cos x in the numerator as well as denominator, your denominator becomes 1 minus cos square x, a plus b, a minus b. And you know what is 1 minus cos square x? This can be written as sin square x, right? So please try to simplify by multiplying numerator as well as denominator by 1 minus cos x. Denominator is pretty easy to simplify. You just simplify first numerator. So solve this now. This is your first hint. So I can be written as 1 minus cos x whole square. I'm multiplying and dividing by 1 minus cos x of this whole expression. And this denominator becomes 1 plus cos x into 1 minus cos x, which is a plus b, a minus b, a square, which is 1 square, which is 1, minus cos square x dx. So I can be written like this. If you multiply and divide by 1 minus cos x. And essentially you are just multiplying by 1. Now your denominator becomes sin square x, but please simplify the numerator part. Fatafat. We will try to maximize the number of questions today, which is very important, because if you want practice these concepts, then I mean you will understand them for once, but they won't stay in the memory lane forever. Forever that would be very difficult, but still we need to remember these concepts. For that we need a sufficient practice. Yeah, what's numerator? Anyone? 1 plus cos square x minus 2 cos x, and this whole will be divided with sine square x. Am I correct? I believe I am correct because this is nothing but a minus b whole square, and this 1 minus cos square x can be written as sine square x. Now, this sine square x can be taken out with every term. So this can be written as I is equals to 1 upon sine square x, which is nothing but cos square x. Sorry, cos x square x. Then this would be cot square x, because this is cos square x upon sine square x. And then this would be minus 2 cos x divided by sine x into 1 by sine x. So, and why am I writing this? Because I know some differentiation. Oh, sorry, some integration. We know the integration of some functions. I mean, differentiation of tan x is sec square x. Similarly, differentiation of cot x is minus cos x square x. So I know the integration of cos x square x. And we even know the integration of cosec x cot x. So I'm trying to use those formulae here. So this is nothing but, see, first of all, this would become cos x square x. We know that integration of cos x square x, if you see carefully. Then this is cot square x. We don't know the integration of cot square x, but we can change cot square x to cos x square x. And then this is minus 2, this is cot x, and then this is cosec x. We also know the integration of this. So can someone tell me the integration of cos x square x? Anyone? We should have the center page, guys. This won't work like this. Please try to gather your center page that we have discussed. Yeah, minus cot x. Okay, how can we integrate cot square x? We don't have a formula directly for cot square x. How do we integrate cot square x? We need to change. We know the integration of cosec square x, right? So we need to change cot square x into cosec square x. Can we do that? Oh, whereas cot square x can be written as 1 plus cosec square x, no? Sorry, cosec square x minus 1. This cot square x can be written as cosec square x minus 1. And we know the integration of cosec square x as well as minus 1. So this is nothing but integration of cosec square x minus 1 into dx minus 2. Can someone tell me the integration of cot x into cosec x? Cot x cosec x. What is the differentiation of cosec x? Oh God, no. This won't work like that. I mean, I would not be able to take class like this. Please try to work on these formulae, and I mean, it's very tough to get through the exam like this. So this would be the integration of, again, cos square x, sorry, cosec square x. This would be minus cot x. Then minus 1 would be minus x plus 2 cosec x plus c. The final answer would be minus 2 cot x plus 2 cosec x minus x plus. Guys, we have already talked about the center page, the importance of center page, that you won't be able to remember every formula. And I do know that, I understand that, but I don't think you guys are that dumb that I will keep saying this again and again and you won't understand this. Either you have to answer me when I ask you the formula part, or you have to carry your center page in the class. So please, I understand. If I understand you and I tell you to do something, please try to do that. Okay, so this was a basic question. I don't know why you didn't attempt this and why are we wasting time on these questions, but still we have to if you're not uh, working hard enough. So that is a problem, and that has been a problem for some time now. I have been observing this. Yeah. Now this question, second one is important. Cos x minus sin x upon 1 plus sin 2x. Why? Because this expression 1 plus sin x and 1 minus sin 2x, both of these expressions are important. So before solving the final question, I would first I'll remove this and I'll do this question. Yeah. So this is cos x minus sin x divided by 1 plus sin 2x into dx. So before we proceed to the question, I would like to tell you the importance of this expression 1 plus sin 2x. So understand 1 plus sin 2x first. Now this one, I'm writing this one as sin square x plus cos square x. Okay, sin square x plus cos square x is 1. And this sin 2x, the formula for sin 2x is 2 sin x cos x. Now this is a plus b whole square actually. If you see this closely, this is nothing but sin x plus cos x whole square. So if you apply minus here, then there is a minus here, and then there is a minus here. So 1 plus sin 2x can be written as sin x plus cos x whole square, and 1 minus sin 2x can be written as sin x minus cos x whole square. This is important. Okay. Because whenever you see this expression, you can always write this expression in the form of this. And see, now observe your numerator. Numerator is cos x minus sin x. This 1 plus sin 2x can be written as sin x plus cos x whole square. So that gives you your substitution. That gives you your substitution. Now, let's come back to the question. So this particular expression can be written as cos x minus sin x as it is in the numerator, and this 1 plus sin 2x as sin x plus cos x whole square. Now, can you tell me how can we solve this? Anyone? It's a direct question now. There's nothing to, I mean, it's very easy. It's direct in front of your eyes. I get it that sometimes we are not able to find the right answer, but at least answer, no? Yeah, Shahid, correct. Uh, Austin, we want to, but how do we? I mean, we surely want to cancel this numerator term, but how do we cancel this numerator term? And Shahid, you are correct, but what is that term which needs to be? No, they both are not same. If numerator and denominator both are same, then I would definitely cancel them. But numerator is cos x minus sin x and denominator is cos x plus sin x. So I can't actually cancel them. Otherwise, I would have. But yeah, we can apply substitution directly. And if you see that if you put sin x plus cos x as t, so put sin x plus cos x as t, then you will see that this numerator along with dx is become dt. So differentiating both sides with respect to t, this sin x, differentiation of sin x is cos x, and then differentiation of x is dx by dt, plus differentiation of cos x is minus sin x, and then differentiation of x with respect to t is dx by dt, and then differentiation of t with respect to t is 1. So you can clearly see that dt can go to the right hand side, and this becomes cos x minus sin x into dx by dt, but I am taking dt to the right hand side. So there are two equations which will help in reducing the original function. You can directly use these two equations to solve your integration part. So this is nothing but I is equals to this whole numerator becomes dt and this becomes t square, right? So this is nothing but t to the power minus 2 dt, which will be t to the power minus 2 plus 1 divided by minus 1 plus c. So minus 1 upon t. T is sin x plus cos x. This is the final answer. So it was an important question. Will be asked in different formats. I mean, with different values, but the concept remains same. You have to convert your denominator into the form of sin x plus cos x or sin x minus cos x. Something like that. Your numerator decides how would you be converting this form. Like in this case, the numerator was cos x minus sin x. So as soon as I saw that the numerator is cos x minus sin x, I knew that I have to form sin x plus cos x in the denominator. It can be cos x plus sin x as well, or sin x plus cos x. In that case, I would try to form sin x minus cos x in the denominator. Both should have opposite side. If there is plus in one equation, then there should be negative in another equation, because that is how the derivative part forms. Sin x का तो cos x ही होगा, but cos x का minus sin x होगा derivative. तो इसलिए साइन डिफरेंट होना चाहिए. अगर ऊपर न्यूमरेटर में cos x minus sin x था, तो नीचे cos x plus sin x होना चाहिए, बनना चाहिए. Then only I would be able to solve the question. So there would be a different variety when they will give you cos x plus sin x in the numerator and 1 minus sin 2x in the denominator. But that is again the same. Concept is same. Aren't you done? Okay. Please mark question number 22, page 307. Please mark this question. You guys, everybody has to solve this. Guys, I really don't know why do you stop solving questions, but I'm I'm irritated with the fact that you guys are not solving the question. So this is an important question. Everybody has to solve this. Because when I ask you questions, you don't answer. So what does that mean? I mean, चलो फिर एक और पहले इससे ही करो एक्सरसाइज से ये वाला क्वेश्चन सॉल्व करो. You guys have 2-3 minutes. Please try to solve this quickly. Cos 2x plus 2 sin square x divided by cos square x. And I will be taking some extra classes during this whole week. I think we need more classes because I have been canceling the few classes in the past, but it won't happen now. I mean, I'm done with the placement process. So I will not be canceling the classes now. In fact, I'll be taking more classes. So in this week, we will be having like 2-3 extra classes. So can we have an extra class tomorrow at 5 to 6:30, just before your regular class? If anyone has a problem, just send me no, and I'll give you the next option. Okay. Okay, cool. So it means that can we have the class from 5:30? 5:30 to 6:30? That is 1 hour prior to your regular class. Will that be possible for two of you? That is, instead of 1.5 hours, we will only take the class for 1 hour. I believe that will also be tough. Okay. Yeah, no. I get it. So it means that you guys won't be able to take this class from Monday to Friday. Friday can be fine, right? But Monday to Thursday will be no, right? For both of you. Okay. So Friday can be fine. Does that mean yes for Friday? Okay, cool. Okay. In that case, we will have an extra class on coming Friday from 5 to 6:30. And I think Saturdays are off for everyone. Saturday and Sunday. Please correct me if I'm wrong, but I think Saturdays and Sundays are fine for everyone. ठीक है? Okay. ठीक है. तो
Saturday morning will be, everybody will be free? Not?
I have class.
You have class. Okay. ठीक है, cool. Saturday चलो छोड़ते हैं. Sunday we can have an extra class, and Friday we can have an extra class in this week. Okay. So Friday from 5 to 6:30, that is just before your regular class. So there will be an extra class on Friday, 5 to 6:30, as well as on Sunday at the same time, 5 to 6:30. Cool. Cool. Chalo, now let's solve the question, given question. Anybody? Yeah. चलो यार, क्लास तो अरेंज कर लिया इस पर. Cool. The answer is tan x plus c. Chavez, okay. चल बता यार मेरे को पहले सॉल्व कैसे किया. I'm more interested in that. क्यों? Anyone? आंसर तो ठीक ही है आई गेस. शावेज तो बता भी दे फिर सॉल्व कैसे किया है.
Sir, can you hear me?
Yes, now I can. हाँ तो मैं
Sir,
बोल
here
रहा हूँ.
1 minus
How did you solve it?
cos 2x is equal to 1 minus 2 sin square x.
ठीक है.
We
This
take
whole
the 2 sin square x to left side and we
Hmm.
equate it to 1
Hmm.
minus cos 2x.
Hmm.
Then we substitute and cos 2x gets cancelled.
ठीक है, सही बात है. ऐसे ही डायरेक्टली देख यहाँ से भी बोल सकते हैं यही बात. This cos 2x will be 1 minus 2 sin square x.
Yes.
So you can open this cos 2x as 1 minus 2 sin square x plus 2 sin square x divided by cos square x dx. So this 2 sin square x, 2 sin square x gets cancelled out. This becomes 1. So this is nothing but 1 by cos square x, which is sec square x. And the integration of sec square x is tan x.
Tan.
So all the questions from this exercise, this particular exercise, are based on using different trigonometric formulae to your convenience. Now let's take some questions from the second exercise as well. I believe you have covered 6 important formulae in that class, and if you have any problem regarding the formulae part, then you can ask me. So these are some particular functions right, and these particular functions basically involve 6 important functions, and these can be, I don't know whether you have solved them or not, but rather than, if you want to ask me proofs of these, please feel free to ask me these things. Don't even worry about that whether we should ask this or not. Yeah, it is not in your syllabus, like CBSE won't ask you to prove these questions. But yes, if you understand how the proof is working, then you are sure, then you surely will be able to use them in a better case, and your understanding will be definitely better. But for now, I would like you, I mean, everybody has to remember all of these formulae. So I think you have learned these formulae, dx upon x square minus a square. And then, so first, before writing the formulae, first, what I would like is to tell you how to use these formulae. So there are 6 expressions. Okay. These are 6 expressions. Now, how are we, first of all, creating these expressions? These are basically quadratic expressions. So we are telling you or rather than that, we are basically solving quadratic equation in denominator. Now this quadratic equation in denominator can either be of the form of x square minus a square, which means that variable square minus constant square, or constant square minus variable square, or constant square plus variable square. So either you write x square plus a square, or you write a square plus x square, both are same things, right? These three expressions are nothing but quadratic expressions in which the first part is variable square minus constant square, second part is constant square minus variable square. If you see, then both the first and second are same only. Second one is just the negative times of first one. Minus times of first one is second. Your second expression is nothing but minus times of first expression. That is what I am saying, right? And then third is dx upon x square plus a square. Now the three more expressions are the same only. The only difference is that there will be a root in the denominator. So if your if your first equation was dx upon x square minus a square, then it would be root over x square minus a square. Then fifth would be integration dx divided by root over a square minus x square. And your sixth equation would be integration of dx over root x square plus a square. Right? So first, second, third, and same will be fourth, fifth, sixth. Right? Now, let's start with first. So first would be 1 by 2a log of x minus a upon x plus a. So you can just see what is the factors of x square minus a square. X minus a into x plus a minus b into a plus b. That is what I am exactly writing here. X minus a upon x plus a plus c. Now in this case, we will first write a plus x. So you can just factor this a square minus x square. This will be a plus x, a minus x. But in the first part, we have written minus upar, and in the second part, we will write minus niche. So just factorize this. Whatever your expression is, just factorize the expression. Okay. And write the factors with log. Now always remember when will be minus upar and when will be negative in the denominator. How would you remember this? Just remember the first formula. Second will be remembered. I mean, you will be able to remember the second part also with the first part only. So remember the first part, x square minus a square. So x minus a upon x plus a, right? But when you write a square minus x square, this is nothing but minus times of first part, right? So you can also solve this thing as minus times of first part. So the answer of first, now if you take negative here, then you can take negative in the log. So if you remember, if you are writing minus log 2, then this can also be written as log 1 upon 2. Why? Because minus can be taken to the 2 to the power. You can take anything inside the log as the power, if you remember. So this is nothing but you are taking negative to the power. That is why negative is coming in the denominator in the second part. Yeah. So first and second will be your log expressions, and then third is nothing but your tan inverse. So you remember tan inverse x, right? The differentiation of tan inverse x was 1 upon 1 plus x square. Similarly, this expression can be written as 1 by a tan inverse x by a. 1 by a tan inverse x by a, right? Now some more. Let's first, these fourth, fifth, and sixth are easy ones, don't worry. So do you remember the differentiation of sine inverse x? Anyone? What is the differentiation of sine inverse x? 1 over root 1 minus x square. 1 over root 1 minus x square. This is like root over constant square, because this can be written as 1 square minus x square. Similar to this, if you see, constant square minus x square. So this is nothing but sine inverse x by a. And these are pretty easy. You just write log of x plus the same expression. Log of x plus root over x square minus a square, and log of x plus root over x square plus a square. These 6 formulae are important. If you haven't written them in the center page, please write them. And these are basically to help you solve all the quadratic equations. Along with them, I believe that you must have understood some more expressions. I don't know whether you have tried to solve these things or not, but let me ask you first. So with the help of these 6 formulae, we can solve any quadratic equation. Are you aware about that? I believe you must be. I mean, you have
Yes, sir.
already, yeah. So we can also solve any expression with this kind. So let's say if I have dx over root ax square, ax square plus bx plus c, then we can definitely solve this, right? And we can also solve this, because we can use completing the square method, and we can convert them into a perfect square, right? Just give me a minute. Yeah. So we can solve any expression of this kind. Now, along with this, now the important part starts after this, that definitely we can solve these expressions using the completing the method square. But along with this, we can also solve any expression of this kind. तो पहले मेरी बात समझ लो मैं क्या कह रहा हूँ. देखो इसमें हमें क्या करना है, इसमें आपने पढ़ा होगा अभी तक, मुझे लगता है पढ़ ही लिया होगा। कंप्लीटिंग द स्क्वायर लगाइए, यू अप्लाई कंप्लीटिंग द स्क्वायर मेथड। किसके लिए? टू मेक दिस एक्सप्रेशन, दिस क्वाड्रेटिक एक्सप्रेशन a perfect square, right? And then use above 6 rules to solve. Simple है ना? But seventh वाले questions में, have you guys solved this eighth? Have you guys solved this kind of questions like eighth, in which there is a linear expression in the numerator and a quadratic expression in the denominator? No? Acha. Chalo, we will reach to this. But I would like to ask Austin about this. Austin, have you guys solved these type of questions in the last class? Okay. Okay, then we will solve these kind of questions also, because they can also be solved when there is a linear expression in the numerator and there is a quadratic expression in the denominator. Either it can be present in the root or without root. Both are same, right? But I believe all the questions of seventh type up to seventh type you have solved. So let's try to first solve one or two questions, then we will move on to this eighth kind of question, which is again important. ठीक है यार, बस उससे पहले थोड़े क्वेश्चन सॉल्व करो। बताओ मुझे, आता है तुम्हें ये कि नहीं? क्या तुम इसको समझ पाए कि नहीं? क्योंकि ये सब इंपॉर्टेंट होगा, दिस एवरीथिंग इज इंपॉर्टेंट. So I'm leaving this for now. I will tell you what is the approach. I will write the approach here, but before that, let's solve some question. Yeah, so solve this. Please solve this, everyone. फटाफट solve this within like 1-2 minutes. दे तो direct question. And what's the answer?
जी answer, anyone? Guys, do we know this? Did we solve questions like this?
Sir, can I tell?
Yeah, please, please. Sure.
Uh, 1 by 90 into log modulus of 9 plus 5x by 9 minus 5x. Let's see.
That is definitely incorrect, but 1 upon, what did you answer? 1 by? Just the outside log wala part. I want to know that. Okay, so first of all, we need to convert this into the right.
Sir, it's 1 by 90.
1 by 90. No. Okay, good. Yeah, Shahid, correct. A is 3 and x has been changed to 5x. It is 3 square, not 9 square, Shahid. So this can be viewed like two problems. I mean, not, you can approach this in two ways. First way is you just use directly formula. So this is nothing but I is equals to dx by, this is 3 square and this is 5x whole square. So in place of a, it's 3, and in place of x, it would be 5x. You are changing x to 5x. So don't forget to divide the whole answer by 5. Don't forget to divide the whole answer by 5. Use your normal formula, which you have studied. Just remember that you have to divide the whole answer by 5. Okay. So this is 1 by 2a. What is a? A is 3. Then this is log of a square minus x square. It should be x plus a and x minus a. Just don't forget to divide the whole answer by coefficient of x, which is 5. So either you can go through this, which would be, I guess, 1 by 45. No, 30. And then this would be log of 5x plus 3 divided by 5x minus 3 plus c. One way to approach is this. Second way is कि भाई हमें नहीं पता ये 5x क्यों आ रहा है, हमें तो 5x से प्रॉब्लम है, हमने तो x स्क्वायर का फॉर्मूला ही पता है हमें. ठीक है यार, अगर ऐसा करना है तो वो भी कर ही सकते हैं. We can take 25 common. This will be dx by 9 upon 25 minus x square, which is 1 by 25 dx upon, this is 3 by 5 whole square, and then this is x whole square, which is nothing but 1 by 25 into 1 by 2a log of a plus x, and this will be a minus x. My bad. A plus x and a minus x. 3 plus 5x, 3 minus 5x. So we can solve it. This will also give you the same answer. Shayad it is 2 by 3, 1 in by 2 into 3, but this 5 is from 5x. We have to divide the whole answer by coefficient of x. If it's only x, then we are dividing by 1. If it's 2x, if x changes to 2x, then we are dividing by 2. So this 5
is due to the fact that this is not just x, this is 5x. Yeah. Okay. चलो फिर ठीक है. Now ठीक है. Okay. I think you all get this, that how do we proceed the questions like these kinds up to 7th part. Now let's come to the 8th part. Okay. Both of these will be solved in the same format. You can just understand one thing. How to solve this? So we need to convert this px plus q, this linear form, into something of its differentiation, a times of the differentiation of ax square plus bx plus c plus b. We need to find this a and b. We need to find this a and b. Now understand, if we find out a and b, so we will write this numerator part with some transformation, and the transformation will be this: a and b both are real numbers, right? And transformation will be a into differentiation of your denominator, which is a quadratic function, plus b. Now understand, differentiation of quadratic function will be a linear function. If you differentiate x square, it is 2x, right? तो हम ऊपर linear part को, this linear equation px plus q can be actually written as a into differentiation of denominator plus b. Now if you write it like this, what does it change? How will it be solved now? It will be solved very easily. Understand how? Let's call this equation 1. Okay, I'm solving this part. We can also solve the second part in the same way. Okay, so I'm writing this. Now you have written px plus q like this. So in place of px plus q, I am replacing it with this. And I am writing this part separate. Now see what? This question is divided into 2 parts now. The first part is a question of substitution. You substitute ax square plus bx plus c as t, you will get the differentiation of ax square plus bx plus c in the same expression. So this will become dt. So if you take this as t, this will become, whole of this become dt. This is nothing but, this question reduces to like this: a dt divided by t. You believe me, this will be the same expression. Every time you are able to convert this into this form, a into differentiation of denominator plus b, your first part of the question will be always will be like this: a into dt upon t. A is a constant and its integration will be a log t. This integration is nothing but a log t, and t, you know what is t? ax square plus bx plus c. तो भाई फर्स्ट पार्ट तो हो गया सॉल्व, हर बार यही बनेगा. और सेकंड पार्ट, b कांस्टेंट है, ax स्क्वायर प्लस bx प्लस c डिनोमिनेटर में, ये तो तुम अभी सॉल्व करके आए हो. 7th पार्ट यही था, राइट? दिस इज नथिंग बट 7th, right? So this question can be solved like this. Now try to, let's understand this through a question, and that will give us more clarity. Okay, so let's solve this one. Just give me a minute, guys. Yeah, let's solve this one. X minus 1 over root x square minus 1. ठीक है जी, चलो इसको सॉल्व करते हैं. Now ये 8th टाइप का ही क्वेश्चन है. This belongs to the 8th category only, but 8th का second वाला category, that which is a linear expression divided by root over quadratic. This is a linear expression, and in the denominator there is a quadratic equation inside root, right? So if we are able to solve this one, I guess we can understand the rule that we have written better. चलो जी, कैसे शुरू करें? तो first of all, what's the identification? Identification: linear divided by quadratic. Either this or linear divided by root of quadratic. This is the identification. You can see there is a linear quantity, there is a linear expression in the numerator, and there is a root over quadratic expression in the denominator. So definitely this is from the 8th category. Right? Now, how to solve this? To solve this question, you always need to do this. Okay? You always need to do this. You put your linear expression, you understand this, and you will also get why we are doing this. Okay? So you always equate your linear expression is equals to a times derivative of quadratic equation plus b. This is the formula. This is the concept. And why we are writing this, why we are breaking this linear into two parts? First part will help into integration with substitution. And second part can be solved using integration of some particular functions. Right? So that is why we are doing this. Now let's understand how to do this in the when values are given. So this linear expression is x minus 1. Then this would be a times derivative of this quadratic equation. Now you only focus on the quadratic equation. Don't focus whether it's a root or not. Whether if it's a root, we will be able to solve that as well. No worries. And if it is not a root, then we will be able to solve that as well. No worries. Both of them. So don't worry about the root for now. Just focus on the quadratic equation. Tharif, is there a problem with your network connection? Are you able to hear me, Tharif? Okay. So a times derivative of quadratic equation. Now what's the quadratic equation here? X square minus 1. So we need to take the derivative of x square minus 1. I will, I could have done this derivative directly, but we are solving the first question. That is why let's try to do it in the correct way. We need to find this a and b. Okay. So this x minus 1 can be written as a times. Now this derivative is 2x plus b. Right? From this equation, please find out a and b. Can you tell me what's the value of a and what's the value of b? What is the value of a and what is the value of b? To find out a, please compare the coefficient of x both sides. In the left hand side, coefficient of x is 1. In the right hand side, coefficient of x is 2a. Then the constant part. In the left hand side, the constant part is minus 1. In the right hand side, the constant part is only b. You can get the value of a and b from here. A is half and b is minus 1. Which means that you can write your x minus 1 as half into 2x minus 1. Which means that you can write your x minus 1 as this. Use this here. So with the help of A and B, I can write x minus 1 as 1 by 2 into 2x minus 1. Okay, this is my first equation. I'm using my first equation to restructure my original question. So my original question was x minus 1. Instead of x minus 1, I will write it like this, divided by root over x square minus 1. This can be further written as, you take this 1 by 2 common and 2x like this, and then this minus 1 can be written like this. Now you can solve these, both of these parts. You put x square minus 1 as t. This 2x dx will be dt. So for the first part, use substitution. And for the second part, use your formula for particular function. So this first of all, to solve this part, put x square minus 1 as t, and then differentiate with respect to dt. So you will get this 2x dx as dt. So this first part is nothing but 1 by half dt divided by root t. 1 by half dt divided by root t. And for the second part, this is nothing but root over x square minus a square. And if you remember the formula, can someone tell me the formula for this directly? I mean, this is direct if you remember this. X square minus a square with root. Oh, okay. This is nothing direct. This is log of x plus whatever is written. And this will be I is equals to 1 by 2. This will be t to the power minus half. So t to the power half plus half. So this will be t to the power half divided by half. This 2 will get cancelled out. And you will get the final answer, which is t is nothing but root over x square minus 1. So this 2 gets cancelled out with 2. This is t to the power half only. T is x square minus 1. Power half mane root. This is your final answer. So always convert your linear expression something like this. Chalo, then let's try to solve one more. Has everyone noted this? Try to solve this one. This is a good question. I mean, the concept is the same, but this can be calculation tricky. आप इसमें कुछ mistake कर सकते हो calculation करते हुए. Don't make a calculation mistake. Try to solve this. The concept is same, which we have discussed. And you can see this. There is a linear function. There is a linear expression. in numerator and there is a quadratic expression in denominator, and the quadratic expression is without root. So you can directly, apply the formula and try to find out the answer. Convert your linear function, linear expression into the form of a times derivative of quadratic plus b. Find out the value of a and b and use accordingly. And if somebody is facing any problem, please feel free to ask me. I'm here. Anji, what's the value of a and what's the value of b? Anyone? What's the value of a and what's the value of b here? So again, the same format, linear by quadratic, first of all. As soon as I observe that this is linear by quadratic, I know how to solve. I just need to write this linear, that is 5x minus 2, as a times the derivative of this quadratic. Derivative of this quadratic is nothing but 6x plus 2. Start with here, 6x plus 2 plus b. What's the value of a? We can find out directly by comparing the coefficient of x. Now what's the value of b? That we need to solve. Because the constant part this time is 2a plus b, and here it is minus 2. We can find out a by comparing the coefficient of x. Now put this a here and find out b. So I think your b would be minus 34 by 6. Okay, this can be 5 by 3. Yeah. So 5 by 3, 3, 6, 11 by 3. Yeah. Correct. So b is minus 11 by 3 and a is 5 by 6. Now I can write this I as 5 by 6 times 6x plus 2 divided by 3x square plus 2x plus 1 into dx minus 11 by 3 dx upon 3x square plus 2x plus 1. Can we write it like this? Because 5x minus 2 can be written as a times, which is 5 by 6 into cx plus 2 plus b. B is minus 11 by 3. So I've used it here. Hanji, everybody okay with this? If you are facing any problem here, please try to ask me. Don't worry about it. तो हमने 5x minus 2 को ऐसे लिख सकते थे, a और b की वैल्यू निकाली, यहाँ पे पुट कर दी, है ना, और फिर उसको ऊपर खोल के लिख दिया, इसे अलग अलग कर दिया पार्ट, right? Now this first part 5 by 6 into 6x plus 2, we can use substitution here to solve this. So what we can do is we can put this 3x square plus 2x plus 1 as t, right? Then this whole 6x plus 2 into dx will be dt. So put 3x square plus 2x plus 1 as t. This will be 6x plus 2 into dx would be dt, which is here. So your I becomes 5 by 6 outside. This is dt and this is t. And then this is nothing but 11 by 3. Okay. To solve this, we need to first solve this. We need to form it into a perfect square. So I believe that everybody knows how to apply completing the square method. If not, then you can remember how do we do this. So first of all, we make coefficient of x square as 1. In this case, the coefficient of x square is 3. So take 3 common. Then we take the half of the coefficient of x. In this case, the coefficient of x is 2 by 3. Half of it will be 1 by 3. Right? So we take 1 by 3, add its square, and also subtract the same square from the equation. Why did we do that? Because this addition wala square will become a perfect square. And this can be written like this. Okay. So this whole value, actually this, whatever we're seeing currently, can be reduced to this expression. This I becomes what? 5 by 6 is outside. This is nothing but dt and this is t. And then this is nothing but 11 by 3, right? And we take 3 also outside. This is dx divided by x plus 1 by 3 whole square plus this can be written as root 2 by 3 whole square. So this is nothing but x square plus a square, capital X square plus a square. So this is 5 by 6 log of t. You know what is t? Minus this is 11 by 9, and you can use your formula. This is x square plus a square. We know the answer for x square plus a square. Anyone? What is the answer for x square plus a square? Dx upon x square plus a square. 1 by a tan inverse x by a, right? And you know what is a. So 1 by a is root 2 by 3 into tan inverse x. In place of x, it is x plus 1 by 3 divided by a plus c. So your final answer would be for the above question, I is equals to 5 by 6 log of 3x square plus 2x plus 1, right? And this 3 can be cancelled out. This root 2 can also be multiplied above. This becomes 6 tan inverse. This is 3x plus 1 divided by root 2 plus c. This will be a final answer. Okay. So these questions can be lengthy, first of all, can be calculation intensive, tricky, but you need to practice them. क्योंकि एक question यहाँ से आएगा ही आएगा. Most probably there will be a question from this part. Okay. Now let's please finish 7.3, 7.4 both. We will start with 7.5. I guess that is integration of partial fraction. Okay. So in the next class, we will start with integration by partial fraction. Please try to finish up to exercise 7.4 and please ask your doubts in the next class. We will be having 2 extra classes in this week, by the way, one on Friday and one on Sunday. So we will try to finish